Hello everybody and welcome to this episode of Student Builder. I say this episode, I mean the first episode of Student Builder. I had originally intended for it to be a video on how to make a remote control BB-8 droid from Star Wars for less than £20, which is about $35. However, I'm still waiting for the last magnet to arrive and I was bored, so I thought I'd do this in the meantime. If you don't know what a parking sensor is, basically you stick it on the back of your car and as you're reversing, the closer you get to a wall, the quicker the beeps are, so basically you know how close you are to the wall and when to stop reversing. So let's get started. All the things you need are on the desk here. So we'll start off with an Arduino. I must admit I've been a bit of a cheapskate. I got a Cumin, which is a cheap rip-off off Amazon for about £3. I've got a breadboard. I've got the HCSR04 board, which is the ultrasound emitter and receiver. I've got an active buzzer. Make sure you get an active buzzer and not a passive buzzer, by the way. Also, obviously, you've got all the connector clips. You've got the thing to connect the board to the computer, and I don't know why these resistors are there. I'll check them out of the way. And also, if you want to actually install it into a car, then you've got this to attach a 9-volt battery to. So let's get into setting all this up. The first thing I'm going to do is I'm going to attach the 5-volt pin on the Arduino to the positive line on the board. I'm going to attach the ground to the negative line on the board. Actually, I've attached this in the wrong place. That's attached to the 3-volt, or that in the 5-volt, like that. So that's set up. Now we're going to move on to putting the ultrasound onto the board. I've actually been pretty lucky with this because, as you can see, they do label each of the pins on the board. The VCC is basically the power supply. That's going to go to the 5 volts. That's ground, obviously, to the ground, and the trig and the echo pin, they go to whatever pin you define in your program. For me, I think the echo is pin 6 and the trig is pin 5. So we'll stick that in the board like this, and let's start connecting this up. So obviously we want the VCC to go to where are we? The VCC to go to the positive line, like that. We want the ground to go to the ground, like that. I want the echo pin, which is that one, yeah, echo pin to go to pin number 6, and I want the trig pin to go to pin number 5. So that's the ultrasound set up, and now it's time to stick the buzzer on. As you can see, one of the leads is longer than the other. That's the positive, and the shorter one is the negative. So I'm going to attach it to the board like this. If I can get that in. There we go. The positive I'm going to attach to, actually I'll get a bigger one. I'm going to attach to pin 4 on the board, like so. And the negative I'm going to attach to ground. Brilliant. So now this is all set up as we need it to be. Let's go over to the code, and I'll show you the program.
Okay, so here's the program. There should be a link to this in the description. If I forget, then please let me know in the comment section, and I'll stick it up straight away. But let's get started. So this bit here is all on how the ultrasound emitter and receiver works. I'm not going to bother going into that too much because it's quite complicated and it's not really relevant that much to the video. If you don't want to know how this works, like a lot more in depth, etc., then let me know and I'll make a video specifically on the ultrasound. However, in the meantime, really all you need to know is that it returns distance, which is an integer, which is the distance from the board to an object in centimeters. And that integer is then used in the main part of the program here. So let's get started with the first if loop. If the distance is greater or less than even 50 centimeters and it is greater than 0 centimeters, then turn the buzzer on. Why have I chosen 50 here? Well, the reason is when you're reversing, you don't want the frequency of the buzzer to be maximum when you're touching the wall, obviously, because then you'd have crashed, which would defeat the whole purpose of having it in the first place. So instead, you give a 50 centimeter leeway in which the car can stop safely. So second loop is the else if the distance is greater than 51 centimeters but less than 150 centimeters. Turn on the buzzer, delay it by a set amount of time, turn off the buzzer, and delay it by the same amount of time. Now, how have I come to this delay? Well, 10 represents 10 milliseconds, as I've just decided that would be a suitable step, if you will. And the distance here is obviously the distance returned from the ultrasound bit here, but I've minus 50 because of this 50 here. If you change the 50, then just change whatever this value is to whatever you change that value to. The reason I've put the minus 50 there is because basically you want the frequency to increase of the buzzer to increase so that pretty much it's going completely uninterrupted by the time it gets to 50 centimeters. But if you do that without the minus 50, you're not going to get that. It's going to beep reasonably fast and then just all of a sudden cut to going on constantly. So by putting the minus 50, I've basically moved the buzzer frequencies back by 50 centimeters. This else if loop here is if the distance is greater than 151 centimeters but less than 200 centimeters, then again you do exactly the same here, apart from the delay is set at 1 second. And the final else if loop is if the distance is greater than 200 meters or 200 centimeters even, then the buzzer is just turned off. That obviously stops all sorts of things, like the really annoying noise that would happen if you carried on throughout. And also it gives a bit of leeway to stop it from going off when cars are too close or whatever. Although 2 meters might be a bit ambitious for that, you might want to change that and lower it a little bit. But that's really all you need to know for the program. Now we'll download it onto the board and we'll see if it works.
Right, okay. I cut off the coding bit a little bit early because I was blabbering on a bit, so I decided to end it there. Didn't need to hear any of the stuff I was going on about. So now is the time we've really all been waiting for. Does it actually work? So I've downloaded it all via the Arduino software, and now let's try it out. So to test it, I'm going to use the 9-volt battery because it's just a lot more portable. So let's plug it in. Right. Cool. So now let's start to work properly, and you can hear the really annoying beep. Let's give it a go. So at the moment we're within the half a meter range, so the beep's consistent. And as we move away, hopefully, if it works, let's put this on there like that. We should find the beep gets slower and slower, and slower and slower and slower and slower the further we move away, which it does. Brilliant. So we now have there you go, a working parking sensor. Okay, so that's that. That's the end of the video, guys. I hope you've enjoyed this. Like I said, my next video should be how to make a remote controlled BB-8 droid for less than £20. So if you're interested in that, give us a sub, and that should be out in the next couple of days, hopefully. If you guys have anything that you want to know, any cool projects you've been thinking about but you don't know how to deal with the Arduino or anything like that, then let me know and I'll give it a go. My uni is finished at the moment now, so I've got absolutely nothing to do for the next 3 months. So hit me up with project ideas that you'd like to see, and I'll be sure to get on them straight away. But yeah, thanks guys. There should be a list of all the parts needed and a link to the code in the description. If I've forgotten to do that, which probably I have, then let me know in the comments section, and I'll put them in there straight away. But yeah, thanks for watching guys. If you like the video, then leave a like, and hopefully I'll see you next time.